Our next session is titled Applications of Causal Modeling for Product and Marketing. It will be led by Rishank Jildial. He's the Senior Manager of Analytics at Audible, an Amazon company. He spearheads the building of analytical foundation for various high growth initiatives on Amazon services through data engineering, data science, and machine learning techniques. Please join me in welcoming Rishank to the stage.
Do you have the clicker here somewhere? Thank you. Can everyone hear me okay? All right. Hi, everyone. I'm Rishank, and today I'm going to talk to you about causal modeling, specifically as it pertains to product and marketing. What we're going to talk about is how you can first think about building these types of models and then leveraging them and democratizing them across your product and marketing teams. Just a quick note, Amazon and the subsidiary Audible, they have a myriad set of models, and this is not representative of any particular model that they use. But this is something that my team and I are trying to democratize and build out and improve upon every day. So with that note, let's get started. So I'm going to read this out. This is a Wikipedia definition of causal inference. Causal inference is the process of drawing a conclusion about a causal connection based on the conditions of the occurrence of an effect. It's a bit of a mouthful. What does that mean? It means there's a stimulus out there in the world, and that lends itself, it exerts an influence on your product or your retail ecosystem. And that, to analyze it without having some sort of an A/B test or a controlled experiment, causal inference is a set of models that allows us to do that. Now, the question is, why should we care? And I alluded to this just a second ago. There are a lot of times when you cannot A/B test things. This may be because you have a marketing campaign that has less, it just is associated with low traffic. So giving away half of the traffic to something that's business as usual, not great. There are other times when you're just massively revamping your product and you can't have half the people see the old product and half the people see the new product for a little bit of time before you gravitate completely to the new product. There are also other use cases where you just can't A/B test for a variety of reasons. They may be legal, they may be ethical, whatever it may be. Um, and as various speakers have alluded to in the past, there's a problem of communication. And that's why we're talking about team building and we're talking about how we should have, I think the prior speaker talked about data product managers, which I think is a really good idea. But the idea is that a lot of different people don't talk to each other across various teams. So there are events where that pass and marketers and or product managers come to you and say, hey, I want this analyzed and I don't know how to do this. And at that point of time, your analyst or data scientist could do some sort of descriptive analysis, but that's usually subpar. And that's because you don't know how something would have behaved in the absence of that stimulus. So this is where causal inference comes in. It helps you understand your business more deeply. It allows you to talk to these various business stakeholders better and arms your data scientists and your analysts with the power to give you a definitive answer that's closer to the truth than you would get with a naive analysis through some sort of descriptive statistics. Okay, so I think everybody likes to think of their data as residing in a data lake. And that's a big buzzword that everybody's talking about. But let's extend that analogy a bit and let's think about this lake having data that you're now mining for causal inferences. So at the bottom, you have this gold boolean, which is the A/B testing, because that's the gold standard. And as I mentioned, oftentimes you just don't have an opportunity to A/B test things. So then maybe what you want to do is you want to fish for other things. In this case, fish. So there are various other types of causal models that you could leverage. There are many out there in the world, so there's a lot more fish in this lake. But we're going to talk about two of them specifically. Those are time series causal models and synthetic cohort models. And I'll talk about them in depth. So I'm going to start with a sports reference. But before I get there, I want us to put our marketing hats on and think about Kawhi Leonard, this gentleman here, as your marketing campaign or your new product that you're launching, and his performance being the impact on your metric. May it be engagement, may it be some sort of revenue metric, may it be LTV, whatever it may be. So now let's get to this example with that analogy in place. So assume you're Kawhi Leonard's PR manager, and you're tasked with calculating the growth in popularity Kawhi has gained because of his performance in the NBA playoffs. Now, for those of you who don't know, which I think most people do, any Raptors fans in the house? Oh wow, quite a few. All right. So for those of you who don't know about him, this gentleman has been pretty instrumental in getting the Toronto Raptors to win their first NBA Finals and their first NBA championships, which is a big deal. So he's pretty popular right now. What's also interesting about Kawhi Leonard is that he does not have any social media presence. So it becomes relatively hard to gauge his popularity through traditional social media like Twitter or Facebook. You could look at the number of mentions he has. You could, for Facebook, you could look at the number of videos dedicated to him, the type of mentions he has. But these are all disparate data sources that don't correlate too well, and because they have different weights to them, it becomes a complex problem. So one of the simpler ways to do this would be to look at his Wikipedia page hits, because that's kind of a really clean data set. Okay, so let's assume that as his PR manager, you are diving deep into this. Now, you could start off with a really naive analysis, and I apologize if you can't see any of the numbers there, and I'll talk about them in a second. But what I've done here is, as a naive first cut, what I've looked at is one of his teammates named Kyle Lowry, whose Wikipedia page hits are on the graph on the right in red, and Kawhi Leonard is on the left in blue. So what you'll notice is that there's an effect. Clearly, they won the NBA Finals, and there's a massive spike at the end, which is, I think, June 14th. And Kawhi Leonard's Wikipedia page hits are about 80,000, while Kyle Lowry's are about 30,000. So, yes, there's an impact of them just winning the finals, them actually going to the finals, them actually being in the playoffs. But how much of this is because of Kawhi Leonard's performance? Now, there may be some extraneous variables in there, but I think what we can do is we can try and tease that out. And how do we do that? The first thing we do is we try to create a synthetic control. And a synthetic control is essentially creating a Wikipedia digital twin. What does that mean? That means if you're thinking about the popularity of Kawhi Leonard, who's the first person on the top left, you can look at Wikipedia page hits of various other players. In reality, what you would do is you would take every player under the sun, and you would match their Wikipedia page hits through various algorithms to find out how their popularity has changed over time in the pre-period. In this case, the pre-period is defined as anything before the 2019 NBA playoffs, and then find out what those synthetic controls would have behaved like in the post-period, which is essentially during the playoffs and finals. So when we run this through our model, and I've used the Bayesian model here, what we find out is this Kawhi Leonard matches most closely with this unhappy gentleman here named Klay Thompson. And when you do run this through a Bayesian model of sorts, you find out that, very interestingly, Kawhi Leonard matches with mostly the Golden State Warriors. One point to note here is I did a quick and dirty analysis here. The top is the Toronto Raptors roster, and the bottom is the Golden State Warriors roster. And the reason I did this is because you could isolate the effect of them going to the finals, because all of these people went to the finals. Or rather, you can remove that impact. But one of the things you notice is that all these people, except for Jeremy Lin, are all Warriors. So what that means is there's something going on that makes Kawhi Leonard more like a Warrior in terms of the Wikipedia page hits than Jeremy Lin or any of the remaining roster from the Raptors. And this could be because they're all All-Stars. I think the first four are definitely All-Stars, as so is Kawhi Leonard, and so there might be something that's happening there. So, all right. So in practice, what you would do is you would actually create a combined synthetic control of sorts, which could be a mixture of Klay Thompson and DeMarcus Cousins and so on, and create that and find out how they in combination would have behaved in the post period, which is during the playoffs and the finals. So when you do that, you actually start seeing some very interesting results. Here, the synthetic control, which I talked about, let's just say, for the sake of simplicity, it's Klay Thompson. His Wikipedia page hits should have looked like the dotted line that you see in the first graph. And you'll notice that the y-axis is really small, and that's because it's the log transform, but you can exponentialize it. The blue lines, or the blue bands around the dotted lines, are the confidence intervals. So what you notice is that the actuals, which are represented by the dark black lines, are the actuals of Kawhi Leonard's popularity, and that's much higher than the confidence bands, which is a very strong signal that there's a causal impact here. As a matter of fact, the model spits out the posterior probability of the causal impact being 98.5%, which is pretty darn good. And the average lift is about 24% with some sort of confidence bounds. So yes, there may be some extraneous variables that may be contributing to this, but given that we trained our model on something like just a set of players who went to the finals, it's quite likely there was something that Kawhi Leonard did that made him more popular than the rest of the players. Now, we talked a lot about Kawhi Leonard. How does this tie back into your retail ecosystems? So think of these players as markets, or think of these players as channels, or some sort of combination of these avenues that behave similarly in a pre-period. Let me give you an example. So let's say you are thinking of a marketing push in your display channel in the US. You could think of your synthetic control as being a combination or just a singular permutation of, say, SEO or SEM or whatever other channels you have, email, across other marketplaces like US, UK, France, wherever you are in your retail ecosystem, and find out which one is the closest match to US display. And then based on that, you can say that with the absence of this type of an effect that you have, like a marketing push, how would that channel have behaved? And now you're comparing it to how the channel actually behaved, and that gives you a really good causal inference around what that net lift looked like. What does that mean in practice? Again, as I mentioned, you can look at campaign effectiveness and analyze that more effectively. You could look at product launches that are not A/B tested. And one of the other interesting avenues that you can analyze here is the impact of PR announcements. So if your company is doing some sort of a large PR announcement that may impact the market in some way, and then in turn exert an influence on your metrics like LTV or trial take rate or whatever it may be, you can measure that based on this. There are many other models out there that you can leverage for time series modeling for these kinds of analyses. Like I think there's a general additive model that Facebook has launched called Profit. If you have a bunch of analysts that are more financially savvy, you could ask them to do this through ARIMA and TBAS models that are used for financial stock forecasting, or you could look at XGBoost that kicks every other algorithm's ass in Kaggle. So, just based on your whatever your data scientists are comfortable with, you can get them to build these types of models and give you a good assessment of what causal inference looks like. All right, so we talked a bit about that. Let's talk about synthetic cohort models. So synthetic cohort models are a family of models that are used quite widely across various different verticals. Economists use it all the time for econometric models, and if you've read any kind of papers from them, you're quite exposed to these kinds of models. Data scientists use it to analyze how customers are behaving in a certain ecosystem. So let's get serious for a bit. Let's imagine that you are a PM for Super Mario Brothers world, and let's imagine for a second that this world is a real world. You can tell I was an 80s kid. Let's imagine this is a real world, and the levels within this world are a customer journey. So a customer can go through these various levels, which are basically different parts of your customer journey. And let's also assume, bear with me here, that the various other types of characters in the Super Mario Brothers world can take the exact same journey as Mario. They can break bricks, they can collect money, they can power up, and all of that. So Luigi can do it, Wario can do it, this little wizard-like character can do it. And so what you're trying to do as a product manager is you're trying to make sure that the customer keeps coming back. That means the customer is sticky and spends more money with your company. So let's assume that this is the amount of money that your customer is spending or with your company, and not dying is the same as more levels passed or more dollars. Yes, it's a bit of a stretch, but hopefully we're also creating products that don't make our customers want to kill themselves. So, so before I get to that, it is important to note that Mario can do a lot of different things, take on very important actions in reality that make him more sticky, make him less likely to churn out slash die. And one of those is eating a mushroom. Maybe not that kind of mushroom, but in various scenarios, you can look at Mario taking this action, and another scenario, you could assume that Mario has the opportunity to take that action, but chooses not to. So you could extend that assessment and say, all right, Mario can take on more risks, Mario can do various things, kill more enemies, get through levels. While in other cases, if Mario does not take that action, then what happens is that Mario is at a higher risk of dying slash churning in your retail ecosystem. And yeah, so you can pass more levels and continue to be more sticky and create more LTV for your company. So now the question becomes, how important is this action really? In the second scenario, you notice that there's a star and there's a mushroom, and we'll talk about that in a second. But the question is, how do you value these actions? So we can think of various examples of this in real retail ecosystems. For example, if you buy an iCloud storage subscription, you could assess that that means that you're getting more sticky with the Apple ecosystem, and therefore you're going to stay with them for longer and not switch to Android or some other type of phone, and therefore have potentially a higher LTV. You could think about bidding for your first item on eBay or creating an online Starbucks account, whatever it may be, that makes you more sticky and more loyal for that particular retail ecosystem. At a very high level, what this means is a customer takes an important action, that action promotes healthy behavior, and as a consequence of that, the customer becomes more valuable. So if you were to look at two almost identical customers in your ecosystem that do almost everything in the exact same way, they have the same purchasing behavior, they have the same characteristics about them until a certain point when they're given the opportunity to take an action, you may find that a particular action leads them to contribute a lot more LTV to your company than a customer who does not take that action. Inversely, if you find that that action does not lead to any kind of increased LTV or engagement or whatever your success metric is, that means that that action was not important enough. So with that in mind, let's get back to talking about how actions are not created equally. And this, for example, you could think about eBay and that having two different actions. One action could be the first time you bid for a particular product. And the other action could be you actually not bidding, but you buying something outright a la carte from their marketplace. So what action is more important? And how do you strategize and prioritize that in your retail ecosystem to promote that healthy behavior? So to that, what we need to do is we need to go through two different steps, very largely, just two different steps to do this. Very similar to the Wikipedia digital twin that we talked about, we need to create a digital twin of customers in our retail ecosystem. And then, once we do that, we look at how they would behave if they took an action versus did not take an action, and then do some sort of a lift model or an econometric model or a different types of models to find out what the essential lift is associated with that particular action, holding everything else constant. So let's start with the first piece. You're thinking of finding digital twins, and on the left, it's basically no good. None of them match Mario. On the right, it's actually quite good, almost identical, if you will. But in reality, you won't find twins that are as good as the ones on the right. So you'll see some sort of, you will have to work with some error bounds. And so now let's assume that, for the sake of argument, all your customers bucket into one of 10 types of customers as shown here in this universe of Mario. And when you're trying to match all these customers, when you put them through some sort of matching algorithm, they will end up looking like this in an n-dimensional space. In reality, what you would do, again, as I mentioned, is you would look at various purchasing behavior or customer-related behavior. And so in this example of a universe of just 6 different customers, 1 and 3 are pretty close to each other, and 4 and 6 are pretty close to each other. So when you're, for your data scientists, I think a lot of people may already know this, when you're thinking about the goodness of fit of your customers, I like this diagnostic a lot. It's called the KS, I believe it stands for Kolmogorov-Smirnov algorithm, or diagnostic. What is that, Alex? Smirnov, thank you. So I like this diagnostic because it's really visual. It tells you if the lines are overlapping to the closest extent possible, that means your fit is really good. And if the lines are far away, it's not as good. So it's very easy to understand this kind of diagnostic. There are many others. But so now let's talk about, once you've identified the twins, how do you find out what is the impact of twins that have taken the important action versus those that have not? So let's change our analogy here and talk about Mario and Luigi being twins, and this wizard and the shell-like creature being twins. So in this first example, Mario is taking the mushroom, Luigi is not. The second example, the wizard is taking the star, and the shell-like creature is not. So once we do that, we can then put this through our lift model of sorts and find out that there's an incremental LTV. And for Mario, it's Y dollars, and for the wizard, it's Z dollars. So now you have a really good way to assess whether Y is greater than Z or not, and based on a certain type of customer, you could now alter their customer experience, where if Y is greater than Z for everybody, you could show the star first, or get them to interact with the star, or if it's the mushroom, the inverse. And in reality, when you're thinking about a lot of these actions being done simultaneously, or there's some temporal effect associated with these actions, you have some more advanced Markov methods that you can leverage, but I'm not going to get into that. With that in mind, so now you have had your digital twins, and you've had some sort of lift model, so now you can find the causal impact of a person or a customer taking an action. What are some of the common pitfalls associated with this kind of an approach? The first one is that your marketers and your product managers will inevitably game these approaches. And this in practice, I've seen this happen in two different ways. One is they will say, you know what, this is a great action, let's recommend this to everybody. And that'll dilute the value of the action over time. The other action that they could take is auto-signing up customers for that action. So, for example, let's say that the important action here is signing up for an email newsletter, and that generates some additional dollars. A product marketer may say, all right, let's, as soon as a person creates an account, let's auto-sign them up for email newsletters. And that can show much steeper decline function. And that's going to be a problem. So that needs to be kept in mind when you're doing this, or at least know that the value of your action is going to suffer. The other common pitfall is applying this LTV to every customer under the sun. The counterpart to this model is actually creating a likelihood model, which tells us how likely a customer is to take that action or interact with that action. So when you're thinking about building your retail ecosystems and thinking about what kind of actions should be shown, or the potential taken action should be shown to a given customer, that should be largely shown to customers that have a high likelihood as opposed to a low likelihood. So that becomes really important as well. And that could be done, for example, via email or some other kind of targeting that you can use to personalize a certain experience for a given customer. Third one is not addressing the quality of the traffic. And this is where you're thinking about the flywheel, where you are thinking about the value of an action, but you don't realize that there is a deterioration in the quality of your traffic, because of which overall, when you're trying to attribute some sort of a net lift in your lifetime value, that may actually not be what you're expecting it to be, because the overall likelihood of your customers from your traffic is actually deteriorating. So this is the flywheel where you need to keep your acquisition team under check as well. So these are three common pitfalls. Now, the questions then become, what does this mean for product development? So the first thing is you can assess cannibalization versus synergy of various products or actions associated with those products. And this leads you to come up with some really innovative ideas where you can either double down on actions that have synergy and create a new product associated with it, or you could think about addressing cannibalization that's associated with temporal effects across various actions in your ecosystem. That requires a little more of an advanced modeling. Again, with your likelihood models that I talked about, you can assess what are the retention drivers or the revenue impactors per customer. And so when you think about product iterations, this can help you come up with the next set of products that can then increase your the value of your actions, if you will. What does this mean for marketing? A lot of companies out there are plagued with descriptive LTV analyses. And that's a big problem because it doesn't address any of the common pitfalls that I talked about in terms of quality of traffic or in terms of various people taking certain actions and therefore different products having a different incremental impact to your business as usual baseline. So, so using these types of models helps you come up with a predictive LTV based on your likelihood, based on the value of an action, and based on the change you expect with various other actions entering your ecosystem in the form of new products. What this does is it also prevents these religious arguments about attributions from taking place because now you have a single source of truth. And so it doesn't become a he said, she said type of a discussion, but rather a discussion about the North Star metric. And finally, this helps you better understand how one part of the business affects the other when you're launching one product in one part of your business as well versus another product in another part of your business, how you can address those. There are drawbacks to this approach, but I think it's still better than a naive approach. The drawbacks to this approach are that it's sensitive to any kind of change you make in your customer journey, for example. An action may be very closely tied to how a customer sees certain things before that action takes place. So changing your customer journey may require you to reassess the value of these actions. If you don't have information about the quality of your traffic, that can be a problem as well. This is definitely a model that needs to be tweaked and finessed over time. So I would call that more of a limitation. It's still better than the naive approach that hides a lot of the problems. And finally, I think we've talked a lot about democratization of data. So democratization of such approaches is on you guys because these are not intuitive approaches, but once done right and once democratized across your leadership, can be really powerful in figuring out what your predictive lifetime values will be, as well as what kind of performance you should see in the absence of any kind of A/B testing. With that, thank you. Open it up to questions.
Do we have any questions?
All right.
Hi, good afternoon. My question's more about the marketing use case in terms of if you're promoting the product, running some sort of promotion, and looking at you talked a little bit about match control groups and trying to figure out the control for that. How would you think about that in an instance where the products that you're promoting, probably you're making a decision to promote them because they're the best products. There might not be good control matches because there's a very selective. They're being promoted for a reason, and they're not representative of what might be in the rest of your universe.
Right. So this is where you're talking about the unknown unknowns, and so here is where things become more of an art than a science. You could think about comparative products that could be essentially thought of as synthetic control products, if you will, and you could extend the analogies that we've talked about for marketing as well as for actions to products themselves and talk about how those products would have behaved. And based on that, you can create a synthetic control for the next closest product that you're launching with some sort of assumptions in mind. The short answer to your question is that there's no real answer, unfortunately, but I think that's getting closer to what you can do in reality.
Hi, thanks. My question is about the special customer journey moments that you mentioned along the way. Could you speak to how you would go about categorizing those moments and maybe how that would impact how you treat those moments as far as the insights that you gather from them?
I'm not sure I understand the question. What do you mean by categorizing moments?
As in, so we talked a little bit about the likelihood of them occurring as like one variable that would distinguish one moment from another, but are there other considerations that you might consider important?
Well, I mean, it's really up to your current customer journey because you're training your models based on what's happened in the past, so you can predict the future. So I don't think that there's a simple answer to your question, but I think what you can do is you can think about how you can leverage existing data to come up with an assessment of what would happen if you change your customer journey. I'm happy to talk more about this offline because I think it's more of a loaded question.
Okay. Yeah, cool. Thank you.
All right. Well, thank you very much.
Thank you.
All right. It is time for lunch.